So we're talking about our metering devices. We just went through mechanical expansion valves. Let's talk about what's happening now. We're going to electronic is sweeping our industry. Few different versions of this valve that we're running into, but they all work the same way, and really that's the important chunks of this. What I'm going to have is an electric motor that's going to turn a screw. Okay, all of my electronic expansion valves work this way. The screw is going to raise or lower the device that's plugging my hole. That's the concept. I'm still going to have my cone, okay? And my pin is still going to be a cone, and I'm going to drive them closed, and no refrigerant will flow through the hole, right? As I open that up, that hole is going to become larger and larger. That's just how it works, right? The same as my mechanical expansion valves, the same orifice, the same pin, okay? The difference is I'm going to drive my pin up and down with a screw, and I'm going to turn that screw with an electric motor. That's it. So if we look at my drawing here, my liquid refrigerant is going to come in through here.
Look at that.
I might, depending on the model, have a strainer still. Okay? That means my strainer can stop up. All the things that just went wrong with my mechanical valve when that happened are going to happen to this valve.
This is a terrible design.
Terrible.
There needs to be a separate, if they're not gonna make these with a strainer in it, because like,
They do, it's in the bottom.
I know, but you have to take the flare off.
They have an S where it's literally a cube body strain.
But yeah, I mean, that's just
Yeah,
close.
and that would be awesome if every one was that way, right?
Yeah.
But they do exist, okay? So this has been a bit of an evolution, all right? That is the other piece of this. When they first figured out the ability to control this way, they kind of rushed things to market. Now that they've been out here for a while, they're hearing service guys say things like that. How about you give us a screen that we don't have to take apart the whole valve to get to? Yeah, okay, we'll add that. All right, so my refrigerant's gonna flow through my screen, then it's gonna go through my orifice, right? The amount of space between that orifice and my pin is gonna be dictated by my screw. That screw is gonna be in this electric motor. All right, then my refrigerant is passing through my outlet. All rules apply exactly as my mechanical at this point. I have no external equalization. Okay, that's going away. Why?
Because you can fully close.
Because it's electric.
Because now I'm actually measuring the superheat coming out of my evaporator.
Yep.
I'm not trying to simulate it with pressure and springs. I'm going to use
Inputs.
sensors.
Pulse width modulation.
We use sensors. And I'm going to calculate it exactly. Right? So I don't have to compensate. I'm just reading what's coming out. Right? So that's actually simpler.
Yeah.
There's actually less to it. All right? My big red arrows here are going to show me here's my EEV. And this is my subcooler setup. Right? My EEV. My EEV flows into my subcooler and I'm coming out. I've got a temperature sensor on the pipe right there. I've got a pressure transducer right there.
Yep.
Right? Pressure, temperature, refrigerant type, PT chart, calculate superheat. That's all I'm doing. Calculating superheat. Okay? Now, calculating that superheat, something's got to do that. So I can't have just an electronic valve. I got to have an electronic valve controller also. All right? Lots of different versions of that. But we were talking about this with our subcooler. The subcool can control any EEV that's running superheat. Any, doesn't have to be a subcooler. So what does my controller got to see, regardless of what this is? It's got to see the same three things I got to see to calculate superheat. The same three things that my valve mechanically had to know. I got to know the pressure. I got to know the temperature of the suction line. I got to know the refrigerant type. That's why the charge head refrigerant. Yeah. Okay. same three things. This guy's gotta know those same three things to calculate that superheat correctly. And then decide how many turns that valve needs to turn to close that pin or open that pin to get the right amount of refrigerant to flow through it. Okay? Now, a couple things about that. My controller also needs to know how many threads are on that screw from full open to full close. We call that steps. How many times does that thing need to turn to go from one extreme to the other? Right? So I've got to plug that value in here based on my valve manufacturer. How many steps are there? How many exist from full open to full close?
4,500, 6386.
Super common, right? Super common. Okay. Now, how does my valve tell my controller how many steps it's actually open?
Proportional integral derivative.
By closing?
It can't. That's a trick question.
Oh, wait, what?
It's a trick question.
Got him.
Got it? How does my valve
Oh.
tell my controller what position it is actually at?
Doesn't ever listen to the question, but he has an answer
He's got an
every
answer.
time.
It was a great
And
answer.
an opinion.
It was a great answer. It was a great answer. It was still a question we hadn't asked, but it was a great answer. All right. So the question, third time, how does the valve tell the controller how far it is actually open?
It does not.
It cannot do it. It cannot do it. That communication does not exist. My valve cannot tell my controller, I'm open 20%. There is no feedback loop to do that. It can't. All right. So how does my controller know how far my valve's open?
From 0 or 100, it just calculates from that.
It's gonna count, it's just gonna count, right? Right, now here's where things go south, okay? So if it knows 0, let's start at 0, and I wanna open this valve a certain percentage, 20%, and it decides that percentage is, let's say, 800 turns. It's gonna tell that valve to turn 800 times, go 800 steps, right? So then the valve opens 800 times, and it thinks in its mind that it's sitting at that percentage, right? And then it says close a little bit, and it closes a little bit, and it opens a little bit, and it opens. And it's gonna count every time. So when it says go back to 0, if everything worked perfectly, that valve would turn the exact steps that it says until it hits 0. That, in a perfect world, that would work, right? But the reality is, it might miscalculate that by 1/10 of a step out of 2,500. Right? Might be off just that tiny amount. And it sits there and moves constantly, every day, over and over, and that error grows every time until that error becomes a real value. It went from 1,000th of 1%, just didn't matter, to now it's 23%. Because it's been thousands of times that it's moved.
Unplug it.
Nah, you gotta.
That will not fix it.
No,
All right? But we gotta have a way. We gotta have a way. We gotta have a way to fix this. All right? So here's how the industry has decided, because they saw this happen, right? Like, oh crap, that worked for a week. What's going wrong now? All right? The industry recognized this was gonna be a problem. So they all came up with different solutions, and then they all said, hey, look, we need one solution, right? This is getting a little too complex. What are we gonna do? So the industry decided that what we would do is when we send the command to close to 0%, the controller, not the valve, the controller would keep going. It would turn it beyond 0%, all right? Not enough to damage my valve. I don't want to strip out that screw, but I want to correct it. I want it to drive it to 0 and have it mechanically stop, and then tell it to keep trying a little bit. Right? So overdriving past 0 is what the industry decided they would do on the controller. All right. So how do I cause that to happen?
Change the steps.
Go into network.
Go to 0. I can override it in the controller to 0 and force it closed. Okay? Now, what if it's off by more than that little percentage?
That's gonna over.
Do it again.
Well,
Yeah, I can. I can do it 2 or 3 times, and I can make up a bigger percentage of error, right?
First you fail, try.
Okay, now, as a technician, I have the ability to cause this to be off by more than that will fix. I can make this thing be off 100%. How?
Offset.
Well, if my valve is open 100%, or my controller thinks that it's open 100%, and I put my SMA 12 on it, and I change it to anything other than 100%, when I plug them back in, it's gonna think it's at 100% when it's not,
yeah,
right? Wait, what?
that all, make it also short the motor.
All right, so let's think about this. If I also unplug it, and it changes its own value, and then I plug it back in, okay, wait. All right, so if my controller, let's say nothing's wrong, and I create this problem, right? My controller thinks the valve's at 0, and this valve is at 0. All right, here's an example. And then I unplug my valve, and I'm doing something. And my controller says go to 100%.
Oh.
Oops, oopsie. And I plug it back in.
It's at 0.
Oh yeah, my controller thinks that valve is at 100% when in fact it's at 0.
You just goofed, guy.
How's that gonna fix itself? It isn't.
You spoofed its location.
Yeah. All right, okay, this is a problem we can inadvertently create, right? As technicians, because that's why I started by saying, how does the controller know where the valve is? How does the valve tell it? It can't. It's the only way it knows is by counting. And if we dig with that by unplugging it, all right, we gotta be sure we put it back together right.
Yep.
Always.
I think it's the next feature of the
Easy way,
next
always be at 0.
All right, so always 0. That's a good best practice, okay? So what does he mean by that? He means take my SMA 12 that I'm gonna override this thing with, there you go. All
Yeah.
right, my tool that I'm gonna connect to my valve, and I'm gonna force that valve, all right? I can force that valve to 0. Now, here's the danger in forcing it to 0. If I have it apart, if I've taken it apart, I can push the pin right off the end. Yep. That's a really sick feeling when that happens. You just watch $1,000 fall on the floor.
Oh, you can't put it back in?
Good luck. You got 2,500 threads per inch. You think you're gonna start that puppy without stripping it and damaging it in any way?
Oh.
Yeah.
You tried it?
Yes, sir.
Sportman's manual, they say, on initialization, you can set the steps, it's 2,500 to 3,500, and force it closed.
You can say it again?
Like, the series of extra steps for overdriving
Right.
on startup,
Yep.
if it's 2,500 steps, they say set it for 3,500, then close it. And if it's 6836, set it for 6,500 steps.
Damn.
Then set it closed.
Right.
And then you should be,
Yeah, and when you go to 0 and it overdrives, then that's the amount it'll push.
then you're good.
Right.
And then you can set it back to
As long as the
60.
valve is assembled, okay, the point I was making is if you take the valve apart, don't do this. Don't do this. With it apart, don't drive the valve to 0, and then especially beyond 0, okay? And your controller will. So if you take it apart and hook it up to the controller and want to see it move, right? Check 30 to 40%, not 0, okay? All right? If the valve is assembled, here's our best practice on syncing the controller back to my valve. All right? If the valve is assembled, put my SMA 12 on it, drive it to 0, drive it closed, so the valve is physically closed. Then go into my controller and force the value to 0%. So my controller thinks the valve is at 0. Then plug them together.
Yep, you can also just turn off the
All right?
over too to easily force it to 0.
You had a question, Julian?
No, I was just thinking.
All right. Okay, does that make sense? Right? If I unplug my valve, if I unplug it and I'm checking the wires or I'm checking voltages or whatever I'm doing, right? And for any reason I've got my valve unplugged, I want to be sure my controller doesn't change the value it thinks the valve is at. It doesn't try to move the valve, because the valve's not going to move. right? So before I do that, another best practice is go into the controller and force the valve. So you put a force on it and it won't move while you have it unplugged. Does that make sense?
This applies to Sportland, but all Sportland CDS and EEVs, if you are testing a motor's integrity and you don't wanna have to do, like, rip it apart or do anything to see if it moves, you can test the motor windings themselves, black and white, and, should be 100 ohms plus or minus 10%, red and green, 100 ohms plus or minus 10% across all the valves, so. that's
Correct.
everything.
It tells you that in the manual too.
And then,
Yep.
That's for learning.
Now, my SMA 12 has also got 4 lights,
Yep.
right? When I wire that up, it's gonna pulse. It's gonna send two to one side to the other side, okay? When I'm driving that, the red lights are telling me whether I have that resistance and that continuity. If one of the lights stays on, it's got a short. If one of the lights doesn't light at all, it's an open.
Change the steps to lower so you can actually see it too.
Say again.
Change the like if you're checking that to see like which lights are coming on, what I noticed is just turn the steps down and you can actually see the LEDs. Sometimes they flash
The
so
speed,
fast.
right.
you can't see.
Yeah. So my knob is gonna, how fast do I wanna spin this thing, right? And when I'm testing things, I wanna spin it fairly slow. So the slower I go, like you just said, the more I'll be able to see the steps pulsing. I'll see that, the versus pulsing so fast it just looks like it's on.
Right.
Yeah, it's valid point.
KE2s, because you can't set the EEV for 0 in the controller. You can't, as far as I know, right?
No, you can.
You can.
Can you?
Yep, you can also just put in a decal.
Yeah.
So what you may be running into, Alex, is it'll have a minimum setting,
Yeah.
right? And if you try to drive it by like manipulating a value, it
Yeah.
won't go past its minimum setting, but you can't actually force it to 0.
Yeah, it's in the controller in the network.
So, you know how you were saying that the controller's going over the value?
Right.
So on the K2, I remember, I took my SMA and we drove that valve open. Plugged it into the K2. The K2 said it was 120% open.
It did, but that's the control, well,
That's
yeah.
weird.
No, he is right, I remember that.
Said it was 120% open.
Now, was that a Danfoss valve?
No, this was.
That's for
Okay.
EV. I overheard it with the
There's no feedback on the Spolen, I don't know.
So I opened it up to make sure it was fully open. So I know
Right.
I went past it. Plugged it in the K2, it said it was 120% open.
The only thing I can think of though is that maybe we adjusted the overclosure, like.
Yeah,
opening, and
it wasn't
it's
telling
reading
you it was 120% open, it was guessing it was 120% open. So something had changed in its parameters that told it to open to 120%. So it was trying to go to 120%. The fact you had it open is a coincidence.
that. I do remember that, that was a while back ago.
But anyways, yeah. Or you could just set the steps for the overdrive and then close it.
So because that is the standard, right? Many controllers today, once a day at midnight usually, or on schedule, it's going to go to 0%, right? So if you're looking at your temperature graph on your subcooler or whatever, and you see this, the hell? Every day at midnight or 10 o'clock or whatever it is, right? That's because it is programmed to drive to 0. On this Sportland device, there is a dry contact that causes it to go to 0, to overdrive, right? Those 2 wires could go to an EMS system because it's just a dry contact. So all I gotta do is send out my 24 volts and get it back. It's gonna tell it, close. I can force that through just closing a contact to close whenever I want. Well, I'm gonna set that up on a schedule, and once a week I'm gonna drive that 0, right? Most controllers have that feature. A more modern version of the EEV is my pulse valve, and this is becoming more and more common, right? So we're gonna see this happening, all right? Now, there's a couple pieces to this we need to understand. They're really very simple. Once we understand them, it's a big mystery box, just like everything else, until we do. But there's a couple components to this thing that just make it really simple. One is, it's either on or off, right? It's not a percentage, like our mechanical valve and our electronic EEV, that's opening an orifice very finely, right? And throttling how much refrigerant is flowing through that orifice all the time. It's not doing that. It's either filling liquid refrigerant into my evaporator, or it's not.
Yeah.
Right? So it's pulsing. That's why they call
It
it
does have an
pulse.
orifice in it.
What's that?
It does have an orifice in it though.
Has an over
An orifice.
orifice. Right, yeah, sure.
It's, but I mean, it's gonna be oversized
Yep.
more than you would think.
All right, there are my parts. Okay, so there's very few parts inside this thing.
That should be that.
But the concept is gonna be, what I'm gonna do is, I'm gonna try to maintain my evaporator full of liquid refrigerant. This goes back to that whole swing conversation we were having, right? How the heck does that work? Well, I shoot it with a little bit of liquid refrigerant, and when I see that liquid refrigerant boiling off by a rise in superheat, I'm shoot a little bit more, right? I'm just gonna keep sending it these little tiny shots of liquid refrigerant
Fuel injection.
based on my superheat moving up and down. So my superheat's not gonna be as stable, okay? My electronic EEV holds that superheat really flat, right? And if it's not, it's gonna be these gentle waves, right? My pulse valve, my superheat's gonna be real jagged. Okay? Real jagged. The length of my, and we'll talk about pulses here in a second, hold on, let me back up. Okay, so I'm still gonna control superheat, so that means my controller still gotta have a pressure sensor on the suction, still gotta have a temperature sensor on the outlet of my evaporator, still has to know its refrigerant type, right? Same things that go wrong with my electronics as far as that goes, go wrong here. Number one problem with any of these electronic valves are bad sensors or sensors poorly located, right? The zip tie on my sensor, and I use little crappy zip ties, all right? Should that sensor be insulated?
No.
Right, we talked about the bulb, it really not being that critical, right? My temperature sensors, they are.
Yes.
Yeah, we should be insulating our temperature sensors,
Oops.
okay? Not necessarily on our TXVs, but we do on electronics, okay? They just work better that way.
Because it'll be affected.
Do we,
by the
do we need to use mastic and sand and all that good stuff? It would all be better, it would all be better, right? But
phone tape.
best practice is probably not. All right, so this valve, there's a couple maintenance items here. Holy,
That's a screen.
did you know there was a screen inside a pulse valve?
Yeah.
I know that.
I have to remove my truck.
Most people.
I've only worked on one pulse valve the entire time I've been in.
Now, this is Sporlands, okay, there are other manufacturers, this isn't the only one. This is one of the most common that we use today, but I'm sure that this market is gonna see some competition,
I
right?
like pulse valve. They're cool.
Sporlands version does have a screen. It is not an external screen, it is inside.
Then
right?
also it's the same.
It does unscrew just like a solenoid, and there is an O-ring, right? So if I'm gonna change that spring, I could probably reuse the O-ring, but I probably wanna have a couple just in case, right? Might cut that guy going back.
Is it a crush washer or is it a rubber gasket?
No.
It's rubber.
I'm gonna say that one's right, that Dan Foss ones, do not take it apart unless you have another pressure
No,
washer.
I know
Yeah.
that.
Okay.
I know that.
Yep. All right, so it's just a solenoid, right? All I've got is the ability to make a magnetic thing here, lift a pin up and down on an orifice, right? There's my little tiny orifice, okay? That orifice, if you notice, is threaded. I can take it out and put it in a different size, okay? What that means for my startup guys is I can assemble the wrong one, right? I can put the wrong size hole in this guy, right? If I can't make superheat and the thing is trying as hard as it can, it's at 100%, that's one of the things I want to look for, right? Check my screen, while I'm in there, go ahead and pull that orifice out and make sure it's the right one. According to Christian, they're really, really hard material. If you have to drill them out, good luck.
I'm sure it's 100% real stainless steel.
Yeah, it's a real pain in the ass. No, it's a real problem. Okay, so my controller has got to have a different feature than my valve drivers, okay? Now, here's the thing. It's easier, it's simpler. almost every controller we have can control a pulse valve. All right, if we look on our S3C, it says relay 4 solenoid.
Or,
Well, we know what a solenoid is, it's just open or closed. Right? Or my PWM EEV.
Pulse width modulation.
What's, say again?
Pulse width modulation.
All right. What the hell is that?
The length of the pulse.
Yes, it's essentially the same as a solenoid valve, where it's gonna,
What does pulse width modulation
so
mean?
it's on time.
It's
It's
gonna open,
send, it's
feed, and
gonna
then
send
close.
power for a certain specific amount of time,
Okay.
and at a specific amount of time, so every.
So we call these pulse valves, right? But their real name is pulse width modulation. Valve.
Pulse valve.
All right? Pulse valve's a little easier. What the hell is pulse valve? Pulse width modulation. Pulse width modulation is not new to us, all right? We've used pulse width modulation before. We've seen this before. So we need to understand this concept, because this concept allows us to go from digital, on or off, to analog, percentages.
Yes.
Right? That's what this technology is all about. This whole idea is taking something that simply can either be on or off and running it a percentage, right? Which is an analog value, okay? Pulse width modulation ties the two together. Here's how it does it, right? And another example of this, other than this valve, is digital compressors, IDCMs, digital compressors, loading and unloading. Right? That's pulse width modulation. Another is fluorescent lights in a Walmart. You walk in there and you see the lights sitting there at 30%, 40%. You walk in the EDC room and you hear click, 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 click. Right? It's the timing of the clicks that are telling it what percentage to dim lights to. Right? This is not new technology. It's been around a long time. But now we're applying it in a different way. Okay? For us, pulse width modulation valve, most of our controllers, and this is in the controller, not the valve, all right? Most of our controllers are designed to run 6-second pulses. Okay? So what does that mean? 6-second pulse. That means I'm going to turn that valve on or off based on the percentage that I want it to run of 6 seconds. Give you a practical example. 50% is pretty simple, right? 50% is half the time. Ding, ding, he's over there flashing B3. That means if I'm gonna run my pulse valve 50%, I'm gonna turn it on for 3 of its 6 seconds. It's gonna click, open, 1,000, 2,000, 3,000, click, closed. 1,000, 2,000, 3,000, click, open, new cycle. 1,000, 2, right? Okay, that's what pulse width modulation is. That's how my valve, my old controller, my ancient controller can say, open that valve 50%, and my relay, because that's all it is, will make it open 50%. Right? That's why my IDCM on my compressor, it's a 20-second cycle. 50% is it loads for 10 seconds, then it unloads for 10 seconds, then it loads for 10, then it unloads for 10. All right, fellas.
No, it doesn't have
I think
2,500
we're,
steps. If you
we're
don't
out.
want it.
Way ahead. Thank you.
Thanks for watching. If you're willing, give this video a thumbs up and drop us a comment. Don't forget to hit that bell icon to stay updated with all of our future videos. And as a quick reminder, HVAC School isn't just a YouTube channel. Dive deeper with us at our main website, hvacrschool.com. Curious for more knowledge on the go? We've got you covered. Tune into the HVAC School podcast, available on all your favorite podcast apps. And while you're at it, join our thriving Facebook group. Also, don't miss out on our free mobile applications available for both iPhone and Android. We're all about community. For techs, by techs.